Hello students, in today's class we are going to learn about a concept in coordinate geometry known as reflection. In order to learn reflection in coordinate geometry, we will borrow the concept of reflection in physics where figures and objects are reflected about a plane mirror in such a way that object distance becomes equal to the image distance. In case of coordinate geometry, points, lines, different figures will be reflected about fixed lines or points which will serve as the mirrors, and these lines can be x-axis, can be y-axis, can be lines parallel to x-axis or y-axis, or the fixed point about which the figures will be reflected can be origin also, and these mirrors, that is the lines or the points, will reflect those points or rather transform the points into different parts of the plane. Let us take some examples to learn the concept of reflection. Look, here I am taking some examples. Here is a point P whose coordinate is 2, 3. X coordinate is 2, that is this distance is 2, and y coordinate is 3, this distance is 3. Now suppose I want to reflect this point P2, 3 about x-axis. Consider x-axis is the mirror. So if the object is here on this side of the mirror, then the object will be reflected and come on to the opposite side of the mirror in such a way that object distance will be equal to the image distance. Now let's find out how much is the object distance. Here is the point 2, 3. So the object distance in this case is this, which is the y coordinate of the point. So the point will get reflected in such a way that it will go on to the other side of the x-axis. How much unit? 3 units. And the point coordinate of the point will be 2, -3. This one, symbolically when we write it in this way. We can directly write the point P is reflected about x-axis as P1 whose coordinate is 2, -3, or we can use a symbol also. The letter capital M represents reflection. The suffix X represents the line of reflection. So when I write Mx of 2, 3, it means the point 2, 3 is reflected about the line x-axis and gets reflected as 2, -3. Okay, let's see if P is reflected about y-axis, what happens? What is P's distance from y-axis? P's distance from y-axis is now 2 units. This was 3 units, okay? P's distance from y-axis is 2 units. Now this serves as the mirror. So point P will get reflected on the other side of this line at a distance equal to the object distance. How much is the distance? This distance is 2. So it will come on to the other side of y-axis, 2 units from it. So its coordinate will now become -2, 3. So we say P when reflected, 2, 3 when reflected about y-axis, the coordinate is -2, 3. The reflection can also take place about a point, and generally the point which we consider in our syllabus, we have the reflection about origin. If point P is reflected about origin, you see it will diametrically come on the opposite side. So if this is 2, 3, if it comes on this side, its coordinate will be -2, -3. That is, both x and y coordinate get changed, and we symbolically write it as MO, that is reflection taking place about origin of point 3, 2, 3, and that point becomes -2, -3. We now discuss the concept of invariant points. Well, the word invariant means which does not vary, does not move, remains in the same place. A point is said to be invariant under reflection about a particular line or about a particular point if the point after reflection remains in the same place where it was before. Let's take this Examples. Here is a point A30. Suppose I want to reflect it about x-axis. Look, the point is on x-axis, therefore its distance from x-axis is 0. So after reflection, it will remain in that same place only. So we will say A when reflected about x-axis, A when reflected about x-axis remains as A only. So we say point A is invariant under reflection about x-axis. But remember, when A is reflected about y-axis, then this point A will come on to 3 units on the left, that is, it will become -30. Okay. So do you understand then? Every point on x-axis will remain invariant under reflection about x-axis. So if in general Px0 is a point on x-axis, then it will remain invariant under reflection about x-axis, whatever x may be. So we can write every point Px0 on x-axis is invariant under reflection about x-axis. Similarly, if you consider the point B02, which is on y-axis, and you want to reflect the point about y-axis, its distance from the y-axis is 0. So reflection of B about y-axis will be B itself. B will not move to anywhere else. So we say B is invariant under reflection about y-axis. But the same point B when reflected about x-axis will come on to 0, -2 over here. I am not marking those. So in general, again, we can say that every point on y-axis, which is represented as 0y, every point Q, 0y on y-axis is invariant under reflection about y-axis. Is there a point which is invariant under reflection about x-axis as well as y-axis? Yes, of course there is. 0, 0, the origin, which when you reflected about x-axis will remain there. When you reflect about y-axis will remain there. Origin, when you reflect about the origin itself, will also remain there. So origin is the only point which is reflected about, which remains invariant when reflected about x-axis or y-axis or origin.